Woohoo, we're live. This is Math 40, section 9.2. This is now solving quadratic equations by completing the square. Now, in elementary algebra, I'm not going to expect you to complete the square on your own. It's something I'm going to show you, I'm going to introduce to you, but we're going to quickly move on to 9.3, which will be the formula you're going to remember. However, as you move on in math, as you move on into intermediate and advanced algebra, you will need to be able to complete the square. So it is worth paying attention to now, if you'd like, seeing exactly how I'm going to do it. So I'm going to show you how to do it. So this is completing the square. So the idea is, you'll remember back in 9.1, if we have a perfect square, we can square root both sides. That would be pretty awesome. But sometimes we don't have a perfect square. Look at this. I've got x squared plus 6x plus 5 equals 0. And that is not a perfect square. This is not a perfect square. So we can't use the square root method. But then somebody thought, wait a minute, what if we made it a perfect square? And everyone was like, what? And then the person was like, yeah, I don't know if they actually said it in English or not, but they said probably the Greek equivalent to yeah. And then everyone stood around and was like, wow, if you know how to do this, we should make you king. And then I was king and everyone was happy. It's just a suggestion. You don't have to make me king. I just think I've got some great ideas. Like, you know, we'd get rid of 17. Just get rid of the number entirely. And universal health care, right? Okay, so first thing I'm going to do, that 5, it's not helping us out. As Marie Kondo would say, I am not getting joy from this 5. Although that's a lie. I love 5, but this particular 5 is not helping me out. So let's go ahead. Let's thank the 5 and send it on its way. So I now have x squared plus 6x equals -5. And that 5 is sparking joy on the right-hand side for me. So I'm very happy about this. So now I'm going to do something really interesting. I'm going to use the perfect square formula. So I'll remind you with the perfect square formula. A plus b times a plus b, which is equal to a plus b, the quantity squared, is equal to a squared plus 2ab plus b squared. So what I want is a perfect square, which I have. That's x squared. That gives me that first square. And I don't have anything here. I'm going to put something here that'll be a perfect square. But in the middle, I need 2 times a times b. So here's a. That's the x. And then that means this number 6 is 2 times b. So the first thing I'm going to do is I'm going to take this number and I'm going to either, depending on your perspective, divide it by 2 or multiply by 1/2. I'm going to take half of it. That gives me 3. Okay, this is the perfect square formula. This is the process. Everyone does it a little differently. Of course, I think I do it best. So 1/2 of 6 is 3. And then you take the 3 and you square that and you get 9. Okay, so it's a very special process. Multiply by 1/2, then square. Then you take what you had, right? What this is right there. But then I'm going to add 9 on both sides. And I should have drawn the box on both sides before I put in the 9. So I'm going to kind of cheat and kind of color around it. Oh, smear. Let me take you to Smeary Town. Let me take you to Smeary Town. Okay. So I add 9 on both sides. So I keep the equation balanced. So I'm just introducing a 9. I'm like, hello, equation, this is 9. 9, this is equation. Hey, 9, do you know this equation really needs a number? Hey, equation, do you know 9 was looking for an equation to join? So you can introduce them. I'm introducing the 9 to the equation. And over on the right-hand side, I get 4, which I'm very happy about. Over on the left-hand side, I actually have x squared, and now 3 squared, and in the middle, 2 times x times 3. It's a perfect square. So I put the number in that makes this a perfect square. Now, the really cool thing is, if you follow this process I gave you right here, this will always be a perfect square on the left. On the right, I've got 4, also a perfect square. That was very convenient. And now, square root-orama. I know, you're going to tell me, don't forget, don't forget. And I'm going to say, I won't forget. I'm going to draw it in with some blue. Plus or minus, make sure you don't forget that plus or minus. So over here, I get x plus 3. Over here, I get plus or minus. What's the square root of 4? 2, you're right. I subtract 3 from both sides, and I get x equals negative 3 plus or minus 2. X equals negative 3 plus or minus 2, so x equals negative 3 plus 2, or negative 3 minus 2. This is negative 1. This is negative 5. Shall we check? We don't have a lot of space, but we can try. So our original question was x, oops, sorry, you can't see it, x squared plus 6x plus 5 equals 0. X squared plus 6x plus 5 equals 0. Negative 1 squared plus 6 times negative 1 plus 5 equals 1 minus 6 plus 5. That equals 0. Negative 5 squared plus 6 times negative 5 plus 5 is 25 minus 30 plus 5. That equals 0. It worked. Woohoo! Are you excited? I'm so excited. That's the process of completing the square. And literally, what did we do here? We completed this perfect square. We made the perfect square out of something that, let's be honest, had not really been perfect square. So this is kind of like math version of trash to treasure. Look at this equation I found at the flea market. It didn't quite fit the decor of my living room, so I spruced it up by completing the square. It's like adding, tassels. Okay. Deep breath. You guys ready to do it again? We're going to do it once more here and then once more in the next section. Okay, I've got k squared minus 11k equals negative 24. Super fun. Okay, so this is what I'm going to do. This negative 24 is already over on the right-hand side. That's where I want it to be. But on the left-hand side, I want to look at the number that's right in front of the k, and I'm going to take that number and multiply by 1/2. So far, so good? Okay. Then I'm going to take that number, and now you're going to see why I was sighing a little bit. Negative 11 halves, I'm going to square it. I'm going to have to do this on a calculator. If you don't know, 11 squared is 121. It's positive because we're squaring it all over 4. So yeah, I'm sighing again. Oh, bunny fur. Now I'm going to take the k squared minus 11k equals negative 24. Let me draw myself some squares. Over on the left-hand side, I'm going to add 121/4. Over the right-hand side, I'm going to add 121/4. I'm not thrilled, but it works. Over here, believe it or not, this is a perfect square. Here's the thing. Even if it's not obvious, and this one's really hard to tell, here's the thing. This is what's so great about this process. If you follow this process, the number you get right here After you take 1/2 of the number, that is the number that goes right here. That goes right here. Okay. It's a lot to remember, I know that. Negative 24 plus 121/4. Okay. Over here, I'm going to say, okay, negative 24 over 1 is going to be, what is that? That's going to be 48, negative 96/4, I think. So I've got k minus 11/2 squared equals negative 96/4 plus 121/4, right? Because I'm going to have to combine these. So that means I'm going to get, what am I going to get over here? What is that? That's like 25/4. Okay, so I got 25/4 on the right and k minus 11/2 on the left. Are you guys ready for some magic? Okay, now that we've got everything tucked up and added and ready, then the magic happens. Square root both sides. Woohoo. Notice what's really cool. Over on the left-hand side, I mean, it's still a fraction, but ta-da! But look at what's happening over here. These are both perfect squares. Plus or minus 5 over 2, because the square root of 25, 25 goes to 5, 4 goes to 2. Bam, it all works out. K equals 11/2 plus or minus 5/2. K equals 11/2 plus 5/2, or 11/2 minus 5/2. 16/2 or 6/2. 8 or 3. Kind of woohoo? So the magic here is in this process. Even when everything is really yucky,